Okay, so this is the second of the 2 videos on rate of reaction factors. So I started the last one, and I do recommend you going back to that if you haven't already watched it. But I started it by going through this and what activation energy meant. So I'm just going to quickly remind you that activation is dependent on the reaction. So one reaction might have a different activation energy to another. But unless that energy is not reached, so unless the reaction is not at that temperature it is required to be at, the particles will not collide with each other. Okay, so here we've got a particle colliding with this one here. These two have collided with each other successfully because this had the correct energy. Whereas this one, if it's just a little bit lower than that required energy and it hit here, it would bounce back and it would not react. So there wouldn't be a product being formed. So with that in mind, we're going to look at the last 2 factors. We're going to look at concentration. So here we've got a low concentration and a high concentration of reacting particles. So you can see the difference. Here we've only got a couple of particles of the red, let's say acid, whereas over here we've got multiple more of those particles. Why would this increase rate of reaction? Well, because you're more likely to collide with the red particles if there is more of them. So it's going to be a quicker reaction for the higher concentration. More likely to collide when there's more of them to collide with. So that is simply concentration. The more the particles are there, the higher the concentration. If there is more particles, they're more likely to collide with each other, therefore a reaction is more likely to happen. Remembering that word collides, the collision, means it's when those 2 particles are going to meet each other and they are going to react rather than bouncing off of each other. So that takes us to our last factor, which is pressure. So if we've got a gas reacting with another gas, that's when we look at pressure. So low pressure is when the particles are really far apart, and then high pressure is when the particles are really close together like this. In high and low, they have the same number of particles, because if they were having different number of particles, then that would mean it's low concentration and high concentration. So here we've got the same number of particles. The low one is just more spread out, whereas the high pressure is more compact together. So what does this mean for rate of reaction? Well, here they're more spread out, so they're going to have to move further to hit each other, whereas high pressure is closer together, so they're more likely to collide. So here is where the higher rate of reaction, because particles are closer together, so they're more likely to collide. So that's simply what's happening. The particles here are closer together, so they are more likely to collide, and therefore they're more likely to have a reaction as long as the other conditions are right. So as long as the activation energy is met, the higher pressure is going to react quicker, and you're going to have that product quicker because the particles are going to collide more quickly. So that is a summary of 2 of the factors, and like I said, the other video went through the other factors for rate of reaction.